The answers to the back. I've highlighted them in red for you. You can look through. If there's something that you have that's slightly different and you're not sure if it's right or not, you can just put a little star next to it and I can check it out when I come back tomorrow, or just ask somebody around you. But essentially, these are the steps and they could be in a slightly different order, but typically this would be the order you would write it in. Things like steps 3 and 4 in proof 5, these two steps can actually be after the AS is congruent to AS, but they do need to be together, specifically 3 before 4. But this step 5 can show up in step 3, and these two things can be moved down, if that makes any sense. But anyway, let me just go through them real quick. After labeling this diagram, we had the two given angles. Then we had these right angles here based on the perpendicular and the reflexive side. So we have angle 1 and angle 2 are right angles. That's definition of perpendicular. This is the one that I starred in the previous proof on the last page. Anytime you see perpendicular, you're going to get two steps out of it. Definition of perpendicular is why they are right angles. And then you say the angles are congruent by all right angles are congruent. Finally, we have the reflexive step. AS is congruent to AS, reflexive property. And then we have angle, angle, side is congruent to angle, angle, side for the reason that the two triangles are congruent. All right, not too bad. If we go to number 6, you could see that we have the congruent segments. CE is congruent to DE. We have the parallel lines, which once again, they don't give you congruence, they just give you parallel. So what you get from parallel lines are alternate interior angles. We have angle C is congruent to D, and A is congruent to B. I left them as A and B and C and D and didn't put the numbers in just to show you how the proof would look that way. So after the parallel, we have C is congruent to D, or 1's congruent to 2, and A is congruent to B, or 3 is congruent to 4. Those are alternate interior angle theorem. And again, the triangles are congruent by angle, angle, side. The side is after the two angles and not in between, and that's why it's angle, angle, side, and not angle, side, angle. Okay, in proof number 7, we have BAD is congruent to BCD. These are angles, so angle BAD, BAD right here, is congruent to angle BCD up here. And then BD is just cutting in half angle ADC. So the only angle that's getting cut in half here is the one that is at the bottom where the 1 and 2 are. So I'm going to show you that. This is angle ADC. And this is the only angle that's getting cut in half, not the angles 3 and 4 up top. They didn't mention anything about angle ABC, so we can only say that angle 1's congruent to angle 2. Whether you think this angle is bisected up here or not, it doesn't matter. There's not enough information to actually put that down. So we have angle 1 is congruent to angle 2, definition of an angle bisector, and then BD is congruent to itself. That is the reflexive side down in between the two triangles, which gives us triangle ABD is congruent to triangle CBD, the two triangles in the picture by angle, angle, side. Once again, we have an angle, and then a side. Finally, we have a little bit longer of a proof, and in this one, I didn't do my highlighting, so I'm going to do that while I'm going over the proof. So we were given that AR bisects CAB, and because that angle is being bisected, we have angle 3 is congruent to angle 4. That just happens to be the way I numbered them. Okay, you can definitely have this as 1 and 2 if that's what you wanted to call these two angles. I called them 3 and 4. We had another given of perpendicular, and again, when you have a perpendicular given, you're going to get that angles 1 and 2 are right angles, which you could have called angle 3 and 4, but I called them 1 and 2 down here. That's an A, by the way, this little thing here. Then I say that the two angles are congruent to each other. After I called them right angles, all right angles are congruent. And then AR is congruent to itself. Well, that's our reflexive piece down the middle. That's one that we should always be looking for. It's like a freebie, and if we have it, then you got to go with it. That's our reflexive property. And then finally, we have that the triangles are congruent by angle, side, angle. And this one, we have the angle followed by the side and followed by the angle, and that is the order they go in. So I'm not sure what you thought about these. I hope they were okay. Again, if you're having trouble, I can kind of assess that when I get back tomorrow. We can have a conversation about what things you did get and what things you didn't get, and we can move on. If you're feeling like everything's going well, I'm going to be honest with you, the proofs do get a little longer, not much, and there are some complicated things that we might come across, but this is the basic. This is really the basis of what we're doing. If you're getting this, or if you're sort of like, ooh, I had that step sort of right, or I didn't know what the reason was here, but you get the general idea, then I think you're going to be fine in this unit, and I wouldn't freak out. And you know me, I'm going to work with you guys as best as I can, and if you have any questions, I want you to come down to my room and get some help. So we'll get there, all right? I promise. Good luck with these. Hopefully they made sense. We'll talk tomorrow. And I do have my snow day sign on my desk. Seems like we're going to get some snow overnight and tomorrow. Fingers crossed. Maybe we all get an extra day to rest, okay? If not, I'll see you tomorrow and miss you guys.